Hello folks, let's start with the chapter 3 now. We finished the chapter 1 and 2, now it's a chapter 3, trigonometric functions. In the previous, in your 10th standard, we have studied the functions in trigonometry. The angles that were given, they were all in degrees. Now there is a slight change. We are also going to learn these angles in yet another system of measuring the angles, that is called as radians. So we are going to convert from degree to radians and from radians to degree. That is going to be your question number 1 and question number 2. So this is our part 1 video, and in this part 1 we will probably take question 1 and question 2. So it is a conversion of degree to radians and radians to degree as per whatever angle is given to us. Let's see the question number 1. Question number 1 says, find the radian measure corresponding to the following degree measure. So degree measure is given to us, we have to convert it into radian measure, and there is a straightforward formula. Whenever you are given a thing in a particular angle in degree and they ask us to convert in radian, you have to multiply by pi by 180. That time you will get the radian measure. So the first angle that's given to us here is 25 degree. You have to multiply it into and get it into radians. Please remember that we will always multiply pi by 180. That time you will be able to get the radian measure. And radian, see how we used to put degree like that, one small zero like thing on top of the angle. Similarly for radians, we will put a small c on the top of the measure that we are getting. So let us see now how to go about doing it. As we said, we will multiply pi by 180. So to get the radian measure, we have it tabulated so that every time we do not write these things again and again. So we do it in table form. Now it is 25 into pi by 180, and pi for us is just our normal pi, 22 upon 7. So you can leave it like this, 25 pi by 180 radians, that's a correct answer, or 25 and 180 you can reduce and write it, that is a correct answer. So maybe here we can do this, just this reducing part. 5 5s are, and 5 how many times? 5 3s are 15, and there is 36. So maybe you can call it as 5 pi by 36 radians. We put that c on top, that is radians. So that is about 25 degree. That's how it gets converted. Our next angle is minus 47 degree 30 minutes. Now degree is further subdivided into minutes and seconds. So we have minus 47 degree 30 seconds. That is our next. Let me check. Minus 47 degree 30 second. Yes. So that is the correct answer, correct question. Now let us see how to go about doing this. See, minus, let's keep it outside. It is like writing 47 degree plus 30 minutes. See, 1 degree, we'll keep it in our mind, 1 degree is 60 minutes. That's a conversion. Now, so 30 minutes obviously is going to be 0.5 degree or half degree, right? So we'll keep that in mind. So this is half a degree or 0.5 degree. So like that, this will come to minus 47.5 degree, right? Actually, I mean, that's just the working that we are doing. And now to get it into radians, what we will do is we'll multiply by pi, multiply this expression by pi by 180. Then we have to do the normal procedures. Whatever way we can cut, we will cut it and we get the answer. Now, probably for little simple working, 475 by 1800. That's your wish. You get it converted in whatever way you want, and then you try to reduce it and see what answer you're getting. I don't know, I wonder if you'll get 25, whether it's a common factor. Okay, let's not take a risk, let's go by 5. 5 9s are 45, 2 remains, 5 5s are 45. Sorry, yeah, 5 5s are 25. Then 5 3s are 15, and then we have 3, so 360. Again, we could have a 5. Yeah, there's a 5 common factor. 5 1s are 5, and 5 9s are 45. Then again 5 7s are 35, and we have 1 2. Right. So this reduces to minus 19 pi by 72 radians. So that's how we get it converted into radians. 1 degree is 60 minutes and 1 minute is 60 seconds. Whenever required, we will use that. So that is our second subpart. The third subpart says that it is 240 degree. This is 240 degree, and this is pretty simple as compared to the previous ones. We know we are going to multiply it by pi by 180, and this is easy. It is very easily there in the table of 60. 63s are and 64s are. So 63s are, 64s are. Answer is 4 pi by 3 radians. Yeah, pretty simple. Then next one, it is 520. Yes, it's 520. Again, this is pretty simple like that. 520 into pi by 180. Okay, let's cut the 0 first and then we'll think about the remaining. 52 and 18, we're not sure. 52 is divisible by 4 but not 18, so let's take 2. 2 9s are and 2 26 times. So like that, this is 26 pi by 9 radians. So this is how we get the things converted into radians. Just multiply by pi by 180. Now we are going to go to the opposite. We are given angles in radians and they ask us to convert the angles and get it in degrees. Now it's just going to be the other way around. Here we were multiplying by pi by 180. So here we will multiply by 180 by pi in order to get whatever angles that we require. The very first one that we have here is 11 by 16. This is 11 by 16 radian given to us. Let's see how to get it into degree. So question number 2. We are getting now into degrees. What will happen? 11 by 16, we have learned it is 180 by pi, and there is an instruction given in the question that wherever pi comes you can take it as 22 upon 7. It is our old good friend 22 upon 7 pi only that is happening here. The pi is that same thing, so we should never forget our old friend, and whenever we require it we will substitute 22 by 7. Okay, so let us work this out and see how this is coming. This is 11 by 16 into 180, 22 upon 7. Obviously the 7 goes to the numerator because 22 by 7 in the denominator, when it comes automatically the 7 will go to the numerator. So now let's solve this. 11 twice, and this I think will be divisible by 4. Let's give it a try. 4 4s are 4 4s are and 2, yeah, 45. That's right. So what are we left with? 45 into 7 by 8. So how much will that come to? Somebody, let's see. 7 5s are 35, 3 carries 31, isn't it? 7 5s are 35, 3 carries 28, yeah, by 8. And let's see now what this is coming to. So many degrees. So 318, 315 divided by 8 will be the degrees. 8 3s are 24, remainder is 7. So 75 9 times 72, 3, then we have 30. So again 3 times 24, we have again how much? 6 left. So we have 60. So 7s are 56, and then we have 4 because of the decimal. So that 3. So you can coolly leave it as 39.375 degree. Now some books, they are slightly fussy and they don't want to leave it like this, and they want to penetrate and get into degrees, into minutes, into seconds, and that way. Basically this is okay if you have the answer like that, but suppose if that is the case, then you will have to take the decimal part and convert it into degrees and minutes, into minutes and seconds. So I will also show you the working as to how you can do it that way. Suppose say you have this 0.375 degree. Now this part is okay, it's fully degree, but the decimal part, if you want to convert it into minutes, then 0.375, if you want to convert it into minutes, we know that 1 degree is 60 minutes. So we have to find out the conversion for this. So therefore actually 0.375 in minutes, it will come to 0.375 into 60. How much does it work to? 7 5s are 30, 3 carries, 42, 45, 4 carries, 18 and 4, 22. So we have 2250, and of course the 0 of the 60, and then finally appropriating it with the decimal, you're getting 22.5. So actually it is in minutes, 22.5 minutes again there's a decimal. So the people who are fussy don't want that 0.5, then you have to convert the 0.5 also, and that will then get converted into second. So 1 minute is 60 seconds. So 0.5 minute will become 30 seconds. Yeah, we saw it earlier. So like that, finally you can get the answer. This 39 degree, we could have it converted as 39 degree, 22 minutes and 30 seconds if you want. Or it's perfectly okay if you leave it that way. So this is how you get the thing converted. Now the remaining subparts, we will take it up in our next part video. Thank you.